This is the right triangle review that you need to go over to prepare to retake the test, or just to study the right triangles. So we're going to start first with Pythagorean theorem. Pythagorean theorem is simply a squared plus b squared is c squared, where c is the hypotenuse, and it is true for all right triangles. If I square one leg and add it to the square of the next leg, it will equal the hypotenuse squared, always, if it's a right triangle. So, if I have a triangle that looks like this, I can take this side and square it, plus this side and square it, and it has to equal this side squared. Okay? Now, Pythagorean triple just means that all three of those sides end up being whole numbers. Because sometimes what happens when I do a squared plus b squared and I'm looking for c squared, I get a decimal. Well, those three numbers together are not a triple because they're not whole numbers. So only certain times will you get all three numbers as whole numbers. So for instance, 3, 4, 5 is a Pythagorean triple because 3 squared plus 4 squared equals 5 squared, and they're all whole numbers. 5, 12, 13 is another Pythagorean triple. So if you're trying to find out if something is a Pythagorean triple, all three numbers have to be whole numbers and they have to work in the Pythagorean theorem. Now you already know how to use the Pythagorean theorem to find a missing side. You just plug it into the formula and work backwards. Okay? So that's not anything new, but what was new this time was we also can use it to determine what kind of triangle I have. Do I have a right triangle? Of course, because if it doesn't equal, then I know it's not right. But also, do I have an obtuse? Because if I do a squared plus b squared and c is really big, see how it stretches out my triangle? I have an obtuse triangle, and I can tell that without even drawing the triangle. If a squared plus b squared is bigger, so c squared is too small, then I have an acute triangle. Okay, because it had to shrink in order to reach over here and match up to C. So if C is too big, the angle's obtuse. If C is too small, the angle's acute. Okay? So you will have to try those out with different numbers. The second thing we did in this lesson was trigonometry. Trigonometry is just another way to find values in right triangles, and often we'll use it when we don't know two sides. If I know two sides already, I can do a squared plus b squared equals c squared. We also use trigonometry when we're looking for an angle, because the Pythagorean theorem won't tell us any angles. So, just as a reminder, we use the word SOHCAHTOA because it stands for sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. So all this is a memory device. It doesn't have anything else to do with your lesson. But in a triangle, when I look here, remember, the side opposite the right angle is always the hypotenuse. So I always just write hypotenuse down first thing. But when I'm talking about angles, I'm always talking about right here, the vertices. Okay? That's an angle. The sides are the lengths that go between those angles. Some of you were mixing up, when do I use sides, when do I use angles? So in SOHCAHTOA, in the trigonometry, these fractions are always fractions of the sides. And I'll show you. So if I was trying to look at this triangle and find the sine of A, first thing I do is go up here to A. And I know sine stands for opposite over hypotenuse. So I'd go down to the opposite and I'd put an 8. And then I'd go over to the hypotenuse and I'd put a 10. So the sine of A is 8 over 10. Okay? The cosine of A, cosine is adjacent over hypotenuse. But I still go right back to A. But now I'm looking for the side next to A, which is 6, and the hypotenuse, which is 10. 6 over 10. And the tangent is opposite over adjacent. So I go back to A, and I do opposite over adjacent, 8 over 6. And I can do the same thing for B. One thing I want you to notice is that the sine of A is 8 over 10. The cosine of B is 8 over 10. The cosine of A is 6 over 10, and the sine of B is 6 over 10. These two are opposites. And the tangent of one is 8 over 6, and the tangent of the other is 6 over 8. They're just reciprocals. So notice, because I really only have three numbers in this triangle to use, they're going to have a relationship between each other that you can notice. Okay? Now the way we use that to find a side is we have typically a problem that looks like this. I have a right triangle. Whoops, I should draw my little mark in here to make sure you know it's a right triangle. And I'm supposed to find side x. Step 1, I figure out which sides are involved in the problem. This side here is adjacent to my 36, and this side is the hypotenuse because it's across from the right angle. So I have the adjacent and hypotenuse. So I'd go back up here and see which of my trig ratios do I want. Adjacent over hypotenuse is cosine. So I know now I'm going to write an equation that uses cosine. So I write cosine of the angle. The angle is always over on this side. Cosine of the angle equals which two sides? Adjacent over hypotenuse. So I do the adjacent over the hypotenuse. That's my equation. And to solve this now in my calculator, I'd multiply this over, and it would be 10 cosine 36 equals x. And that will be my number. Okay? Every equation goes through the same steps. What sides are involved, which of my trig ratios should I use, and what's my answer. So if x is in the numerator, like we just had, cosine 25 equals x over 11, it's going to be a multiplication problem, because this 11 moves over here. Boom. Okay? If x is in the denominator, then I need to swap and do a division problem. So that would look like this. Cosine 61 equals 14 over x. So when would I need this one? Well, sometimes you're trying to find the hypotenuse, and sometimes you're trying to find the adjacent or the opposite. It just depends on how it works out in your SOHCAHTOA equation. So if I have an x down here, I'm actually going to swap these two numbers right here. And then the entire cosine 61 goes down here, and this x goes up here. And I get x equals 14 divided by cosine 61. This is what you're going to put in your calculator. Okay? Those are the two ways that I use trig to find a side. Let's look at how I find an angle. Exact same thing. I look here and I say, oh, here's an x. This side is adjacent. This side is hypotenuse. Adjacent and hypotenuse, that's going to be cosine. So I do the same steps. I first look at the situation and find out which angles do I know, which sides are related to that angle. This is the adjacent side. This is the hypotenuse. And then I decide, is it sine or cosine or tangent? I'm going to do those same exact steps every single time, so I want you to think about them. So I write my equation. The cosine of x, because I don't know what it is, equals adjacent over hypotenuse. So the equation is the same, but where I put things might be different depending on which parts I don't know. But I can't put cosine x in my calculator because it needs a number. So instead we use the inverse function. It'll look like that on your calculator. So we're actually going to enter second cosine. Second button and then cosine, and it's going to give you this. And in the parentheses that follow it, you're going to write 9 divided by 14, or numerator divided by denominator. And then you hit enter, boom, it's going to give you an angle measurement, and that's the angle measurement. So we have a way to go directly to find a side. We use regular sine, cosine, tangent. But when we need to find an angle, we're going to use second sine, second cosine, second tangent. But we use the same numbers. Now, here's an example of a word problem. How tall is this building if its shadow is 36 feet? Here's its shadow, because shadows are always on the ground, and it's 36 feet. And its angle of elevation is 62 degrees. Elevation means it's going up. This angle is 62 degrees. So I have to write and solve an equation. So the first thing I notice is I only have one side, so I can't use Pythagorean theorem to solve it. So I'm going to have to use the trig. So I say, well, here's the angle right here. It seems to me that they have the opposite side, and I have the adjacent side. And I go back and look at my SOHCAHTOA. Tangent is opposite over adjacent. So I would write my equation. Tan of the angle, 62, equals opposite over adjacent. Okay? Now, remember, when I have my number in the denominator, this is a multiplication problem. So to move this away from the x, I'm going to multiply both sides by 36. And I get 36 times the tangent of 62 equals x. And I didn't bring my calculator over here, but I will go get it. That's not awkward at all, is it? Okay, so I'm now going to put in this calculator. 36 times tan 60, whoop, that wasn't right. 36 times tan 62. Okay, and I get 67.7. What does that mean? That means this building here is 67.7 feet tall. Okay, number one, label everything in your picture. Figure out what sides and angles are involved. And depending on which sides or angles that are involved, you'll know whether it's sine, or is it cosine, or is it tangent. Okay? Be sure to do the practice problems that are on the back of the page. If you still don't understand this, watch another video or come into tutoring to get extra help.